make are stable and ensuring that users are even happier, right? And it's very similar to DevOps because as a DevOps engineer, you're also meant to make sure that your systems that you deploy are stable, and that's why the subtitle of my talk is "From Coders to Happy Users," right? So, as a DevOps engineer, what you're expected to do is to be able to work with developers and make sure that the end users are quite happy, right? I'm sure in the past we have seen times where things like Facebook, WhatsApp go down, and we are really sad, right? And in that case, people will be throwing all sort of fire at the guys working at those companies. Mostly because they're unable to use the application, right? A very common example would be your banking application. Times where you're unable to, receive or transfer cash, you're quite frustrated because you're limited, right? And you're not happy. And that's one of the things that make companies have bad record and maybe lose customers because they're unable to maintain their systems. And some of these things are things, a DevOps engineer can also ensure to avoid. And we talk about how some of the methods or tools we use to ensure happy users eventually. So to my first slide, which is going to be I'm not going to have too much text on my slides, just so we're able to see things from a high level. um I'm a diagram guy, so it would most likely be seen out of diagrams instead. But yeah, this is just, I know this is quite a lot at first glance, but I'll try to break through what it looks like and what it entails, right? So yeah, we have been saying DevOps for the past few minutes, and basically DevOps means the development operations, right? And in this context, it's mostly around you work with developers and you also ensure some standards, right, to get applications shipped out to the cloud, right, or to production. There are a lot of stages you would have to undergo as a DevOps engineer, right? And you are not working alone, right? So one key thing about DevOps is the fact that you are not an isolated person, right? So in the past, I'll give an example. In the past, most of the things we do as DevOps today was called system administration, right? And what happens is, someone somewhere or a group of team builds this very big service, right? This big application, and they take it, I mean, in a flash drive or something, right? And they go give it to somebody, which is a system admin, and say, take this code, take this software. Your job is to help us run it somewhere, right? And he would work day and night trying to make sure that that application gets deployed and it gets rolled out. Now, when they have a new version, they go to him again and say, take this code, I want you to deploy it, right? And when you do that process, he might not know that some things have changed, right? Things like some requirements or dependencies. And that's where you see that the application breaks, right? So with introduction of things like agile methodology, for those of us that have done a bit of I think project management also, you might have heard about agile. There we basically you have a committee of people that start together and they were like, okay, it's better to bring all these processes together and let's call it what DevOps, right? Because now we are bringing in both developers and operations together. You don't want them working in silos anymore, in individual groups. You want them working as a team, right? So the operations guys know what dependencies are for the application even before he starts deploying it, right? He's able to communicate properly to them. He's able to understand all the requirements. So looking at my diagram here, on the left-hand side, we have things that mostly, involve development, right? Things that developers focus on. They focus on building, writing code, running tests, right? Unit tests, and automated tests, right? And then when it comes to the right hand side, you have things that operations sort of focus on, deployments, operating the systems, and also monitoring them. And this is mostly the entire flow, right? So on the left, and I'll give you an example. As a developer, you'd most likely want to, be able to write your code with your favorite code editor, right? It can be Sublime Text, it can be VS Code. Once you write that code, you push it up here to a source control or version control system, and this are basically things like your GitHub, your GitLab, your Bitbucket. If you're a badass, you might be hosting your own private version control systems. I think we have some people that do that. And at the same time, you're working with QA guys to make sure that your quality is top notch, right? You have your test passing, right? Your application is not breaking at any point in time. And the operations guys, the DevOps guys would mostly still be following along all of this and just looking out for wherever they can help out, which is mostly part of the job. um, and then you also have the part where you focus on building, right, which is a non-ending process, right? And you can see this is like it's a spiral. It goes over and over again. Developers are getting new feature requests every day, right? You might see that you open Snapchat tomorrow and you find that there's an AI on Snapchat, right? Developers have sat down and wrote a new feature. You can open it next tomorrow and find a new feature, right? So that whole process doesn't end for developers. They keep building new features. And at the same time, as operations guys or DevOps guys, you also want to be in the loop to ensure that you have continuous integration, right? So that when they write code and they push it to source control, they don't have to manually go to Google's office or something to go and run their tests. They can just push, and you would set up automated tests for them, right? So that they can know when their tests are failing and they can fix it, right? Before even going further to deployments. Now, when they ship code, the tests are passing, and they want to release, which is mostly what where you come in fully. At this point, you need to be there completely, because if this goes bad for any reason, you need to be able to fix it or do a rollback, right? So when they're done with their code and they're done testing it and they want to release it to maybe one of the environments they have, environments, I mean things like the test environments or production environments, right? Um, you would come in and make sure that all the infrastructure they need is set up. I won't talk too much about cloud providers in this talk, but then you should understand that when I say infrastructure, it can be infrastructure on Google Cloud, on Azure, on AWS, right? You also have other guys like Red Hat, you have Linode, DigitalOcean, a lot of them, right? But then it doesn't really matter. You just want to know that as a DevOps engineer, you have the infrastructure already provisioned and configured properly for the deployment. Now, the next steps after that is to also help in um, getting that deployed, right? Which you do using some tools, right? So there are a lot of tools that helps um, DevOps engineers perform deployment. We'll talk about those in my next slides. And after that, you won't just stop there, right? But you also want to make sure that and it's been monitored, right? So imagine you release a new feature, for example, today, and you deploy it to production, but you just go to sleep. You don't bother to check if it's breaking, if it's using up too much resources like memory and CPU, right? You just forget about it. And then all of a sudden, the whole application crashes, right? Which is not, might not really be a code problem. You can't put the blame on developers in that case, because you did not properly monitor and see that the new feature they built has a spike, right? And you need to increase your resources like CPU and memory for it. So you basically have to be in the loop right from the start to the finish. Um, and it's a fun process because eventually you can automate a lot of these things, right? Even down to testing the application itself, right? You can automate things like logging into Facebook, posting a new status, and then logging out back. You can do all of that using some test tools, right? And why you were doing that is so that you can test that the whole application is still working as expected, even after developers have pushed a new feature, right? Which is something really cool. I'll talk about tools that can help you achieve all of that. So my next slide is mostly around the planning part, which is going to be this one here, and I'll start with that mostly. And this is a project I was supposed to kick off yesterday. I just brought it up as a very typical use case of what the whole flow is going to be like, right? This is a new project, nothing has been done, but then I was just able to sit down and think that, okay, the first thing I need to do for this project is to set up GitHub Actions, which is my tool that's going to help me build and deploy the application, right? Developers are already building, but then, as a DevOps engineer, you also need to set up the initial pipeline that can help you build and deploy that application. So you have this phase as DevOps engineer where you also sit down and plan the things you want to do. You have to properly break tasks down. The next task here is, configure Helm. So Helm is a package manager. If you have used things like, Linux or Windows, you might have been working with tools like, you have to install an application. You have to go to maybe the store to download it from there. If you have used Linux, you might have worked with things like apt-get, right, to install app packages. And for For applications on Kubernetes, which is something we'll talk about later, a very common tool to package them is known as Helm. So that's why I have this tags here. One of the other tags I have is, set up. Okay, this is duplicates. The next one is provision the cluster, right? So this is quite similar to the infrastructure you have here, up above here, where you have to provision the infrastructure. Make sure that you have the cluster set up, right, where you want to deploy the application. Because imagine building and you don't have an environment to deploy it to, right? What you built is just going to you just have an artifact that you have built. You don't have where to get to deploy to. So that's why you also have to plan out how to deploy. There are things most times when developer build features. So for example, I don't know, I'm using Snapchat as an example. For example, on Snapchat, you'd want to be able to store media files somewhere, right? You're not going to store them on the user's device. You want to store them on the cloud somewhere. So if the developers tell you that, okay, we have a new feature and it allows people to upload pictures, you want to make sure that they have a bucket or a storage, right? And that's why I have something like this. So I've been able to communicate to the developer and understand that they have they have some storage requirements, and we can use GCS for that. There are alternatives like AWS S3, right, and so many other. And then finally, you also know that you want to be able to configure networking, right? You want to make sure that it has things like SSL, that's HTTPS, right? You also want to make sure that you have things like, the domain name is pointing to the right site and all of that. So we'll talk about this looks a bit advanced, but then it's something we'd eventually get to. In the next few weeks during this whole session, right? We would hopefully be able to build and deploy an application and even figure out the networking parts within the next few weeks. So let's talk about the code part, right? If you look at the diagram we had, there's also the code part, which is not restricted to just developers, right? As a DevOps engineer, you should also write some bit of code. And this is a very common question people ask every day, that do you need to learn how to code as a DevOps engineer? The answer is yes, because there are times where you want to make your life easier, right? And you want to do things by standards. So the best thing to do is to be able to write some level of configuration code that can do these things for you. I'll give you an example. If I go back to my previous slide, you would see here I say provision GKE cluster, right? In this sense, I mean that I want to be able to create a Kubernetes cluster on Google Cloud, and I don't want to do that manually. I want to do it by code, and that's where the whole code part comes in. And if you look at this diagram, this on the left you have your code, on the right you have infrastructure, right? So you're basically using code to create stuff on the cloud, right? So I'm using code here to create servers that I want to run my applications on. And that's something that is going to make life super easy for you. Imagine you have a team of 5 DevOps engineers, right? If you went to Google Cloud or AWS and you created these servers manually, they won't know the configuration you use, because they will not really they were not there when you were doing it, right? But then if you want to keep track of everything, you want to document what you did, you can use some particular tools to build up all of the infrastructure you had to go provision on the cloud, right? um yeah, and to the next part, we'll talk about building, right? So let's say the servers are up, where you want to deploy the applications are up. What's the next part you need to do? You need to build, right? So say your developers are writing, they're building the application in Python. Python is a very popular language, so I'll use it a lot. Or they're using JavaScript or Django, right? Or some other language or framework that you have out there. You want to be able to build the code they have written, right, on the server. You might have heard about different tools for building, right? If you have used HTML, you know that HTML just interprets the code you write on the browser. If you have used languages like Java, Java does not actually run the .java file that you write. The code you write in Java needs to be compiled into a particular artifact that you're going to run, right? Which is, I think, is .jar. Um, for things like Python, the interpreter automatically interprets it and it can run on the fly, right? But now when you look at all these languages and all these frameworks, there's you need to understand that you don't just run those code the way they are. You have to build them into something, right? And I'll give you an example. Your mobile applications that you use on your phone are built in different ways, right? And they are written in different ways. So let's say one of your application is written with something like React Native. The developer has to compile it into an APK for your Android phone or into a different format for iOS, right? If he builds the whole system using a different language, right? Maybe Swift for iOS. He has to also compile it into an application that can run on Apple, right? So the major thing is when developers are building, you also need to understand that those code needs to be compiled or built into something that can run on your desired infrastructure, right? So for Java, you have things like JUnit, Gradle, Maven, I believe, is used to build Java applications. Um, for Python, you basically can use the Python interpreter itself. If it's a web application, you can also run the application using Python and then serve it to the web server. For your typical HTML, CSS, you don't really need to build them, but you need to have them run with a web server, right? And that's where things like Nginx comes in, right? So as a DevOps engineer, you need to be able to understand these different languages and how to build them. You don't need to know how to write this, like the code in those languages, right? You just need to understand what the build process is like, and that's something you can always find online. And a very common way of building an application is by making sure they run in containers, right? Which is the Docker part here. So you can have multiple dependencies, multiple requirements for your application, but it's possible to also bring all those configuration and dependencies together into something called a container, which is where we'll talk about Docker. Um, so let's go to the next thing, which is around testing. Imagine a case where developers have built the code, they have planned out the whole thing, they have built a particular feature, and you have been able to also help them bundle it together as an artifact or maybe as a Docker image, right? The next thing is you want to run tests. You don't just say, okay, because you have built, now you should go and deploy. It's very good to run tests so that things don't break. On the deployment environment, right, on the infrastructure itself. And there are already tools for testing, right? You have, if it's a very simple application, like an API, you might have heard the word API, application programming interface. It's a very simple API. You can test it using things like Postman, just to confirm that all the endpoints, right, all the slash this slash that is working, right, all the major endpoints are working fine. For more complex testing, like I said earlier, you want to log into an application, you want to make a post, you want to use certain features of that application, right? And just to see that it's working fine. Things like Selenium would be really useful because with Selenium, you can simulate what an actual user of the application would do eventually, right? With things like Selenium. And you have a lot of other testing tools here. Be sure that you don't need to learn all of them. I don't think I have used more than three on this list, which is Selenium, JMeter, and Postman, right? I really don't even know the rest. So you don't need to learn everything about this. But then just know that it's good for you to understand when necessary, it's good for you to understand how to test applications or how to write automated tests. And this is not something you also do alone. You do it along the DevOps engineer as well. And that's why the whole DevOps movement is not just about you doing all of this alone. It's about you working with the developers to make sure that the application itself can be deployed smoothly eventually. And to my next slide, which is deployment. Now, this is where you have to do a lot of work. This is where you would focus on mostly, because developers would not have so much insight to what deployment is like. You need to understand that there are multiple ways of deploying applications, and you need to pick like the best method. And I'll give you an example. If you have someone building a front-end application, right? There are multiple places you can deploy front-end applications to. Um, if you're feeling like a badass, you can deploy it to Kubernetes, right? So you have to build a container for it and deploy it to Kubernetes. If you want to do things a different other way, you can take that front end and deploy it to places like Netlify, places like GitHub pages, right? Um, you can even deploy your front-end images on a bucket, right? A Google Cloud Storage bucket or an AWS S3 bucket. So there are multiple ways of deploying, and your developers might not have this knowledge. But as a DevOps engineer, you are supposed to be able to evaluate all the options you have and pick the best fit, right? And that best fit does not have to be the best fit forever, but it can be for the meantime, right? So in future, the company might have grown bigger and you guys would have more users, right? In that case, the requirements will be larger. And there are times where you need to review your deployment strategy and see if you need to change some of the tools you're currently using. Like I said previously, you don't need to learn all of these things on my screen. These are basically just different tools for different purposes. If we go down to the deployment part of this image, you'd see things like, okay, can anyone hear me?
Yes, we can.
Okay, I saw a message on the group. Okay, so for deployment part, like I said, you can deploy to any of these environments here. Things like Google Cloud, HashiCorp, AWS, which is Amazon Web Services. You can also deploy to places like Rackspace, Heroku. A few of us might have used Heroku in the past, and there are so many places to deploy your applications to, right? And that's one of the fun parts of being a DevOps engineer, because you are learning tools every day, right? I think at the moment I'm currently learning a tool called Cortex, right, which is something for monitoring, which we might talk about in the next slide. So the thing is, you'd always find yourself learning different tools. It might get overwhelming, but it's actually really fun because you'll be able to bring in the knowledge and experience from a previous tool you have used into a new one, right? So like, just to go over the whole thing again, developers are writing their code, right? You are helping them build this whole code using things like GitHub Actions, Docker containers, JFrog for some particular Java artifacts, right? And a few other technologies like that. The next thing would go to testing. So you can help them write tests, and there are multiple ways to do tests. There are tools that even make tests super easy, but you most likely be doing this with the help of developers. And you move on to releasing the application, right? And when you're about to release, you can use different applications to release, right? And this is where the whole idea of CI/CD comes in, which is something we'll talk about in some slides to come. So there are multiple tools for releasing applications. So this release is also quite similar to deployment. This is the stage where you get the applications ready to go to your deployment environment. Now, for deployment, it's just you triggering the deployment and having it on the server, right? You have to operate those deployments. For example, after it's deployed, you want to be able to check the logs. You want to be able to see how it's performing, if it has changed in the past, if it has changed from the way the past few deployments were working, if this new deployment now requires more resources like CPU, memory, and whatever, right? Which is also quite similar to monitoring, right? You need to also monitor that the application itself is working properly. Now, if it's not, and you realize that, okay, this application, because of this new feature, it has a lot of restarts, it breaks a lot because it uses too much resources, right? It's your job to be able to, you know, add back to this planning. So where you plan on, things like Jira, and where you basically put out all the tasks you want to do. It's your job to be able to say, okay, since this application needs more resources, I'm going to write a ticket that says I should increase the resources for this application so that I can perform better. And then, once you plan that out, you update the code if you're using IAC or GitOps, and then you go back through this whole cycle again. And it's a never-ending process for you and the developers, because they are focusing on building features and you are focusing on ensuring that the features they build are working smoothly on the deployment environment and that users are happy, right? And that way you definitely get a salary increase, right? Which we'll also talk about. So talking about monitoring, a very good part of DevOps is the monitoring aspect, right? And this is something that um, we ignore a lot of times, but it's really important. So just like in life too, where sometimes you're just having your day-to-day life and you don't sit back to reflect, or your health, for example, right? You're just basically living your life and not focused on your health. You need to sometimes take a step back and look at things and look at them from a different point of view. And that's the idea behind monitoring. You don't just want to deploy applications and imagine that they're working fine. You want to have certain metrics you're looking out for to be sure that what you have worked on so far is actually working smoothly. And there are multiple tools for this, right? One of the most popular one, it's a bit advanced also, is Prometheus. It's a tool that helps you monitor metrics, right? To basically see how your application is performing after it's been deployed. You have Kibana, which is from the ELK stack, Elasticsearch, Logstash, and Kibana. You have tools like Dynatrace, which is not my favorite tool, but then people use it, right? You have PagerDuty, which is really cool because imagine that. So I'll give you a scenario. One of the very common things that happen in Nigeria is in schools, right? When registration is on, you have people applying to a particular portal, and all of a sudden the server is down, right? Because there's too much traffic. Now that's where things like monitoring would have come in and fixed, because if they had proper monitoring tools in place, they would have been able to identify quite early that they're going to have a downtime because there's too much traffic. And what's the best thing to do? They will be able to look at their resources and see if they need to scale up, add more resources to the server. Now, when you don't want, and it's funny how sometimes it's the customers that are the ones telling the company that your application is down, right? Your server is down. And that's really bad, right? Because it can bring, you can lose customers definitely that way. And one of the best tools to use to fix that is to have a monitoring tool and an alerting tool, right? So PagerDuty, for example, or even Prometheus can trigger alerts, right? So if your application is down, if something is happening that is not regular, you can set up monitoring and alerts. PagerDuty can go as far as calling you on the phone and telling you that there is a downtime, you should fix it, right? So if you're not with your laptop as a DevOps engineer and you want to be able to monitor things even when you're not there, you can configure a lot of smart tools like this that would help you ensure you have proper monitoring in place, right? Trust me, this is the best part of the job because yeah, I think it's the best. So if we go back a bit, this is quite a lot, and there's so much tools to learn. There's so much, it's a never-ending process. Like I said, you'd have to learn different tools. It's an iterative process because you always realize that there's a better way to do stuff, and you want to pick up a new tool or a better approach, right? To compensate all of this, for you, I had to include a slide that talks about money, right? Because I want to believe some of us likes money, and I think DevOps is one of those jobs that pays really well. And I think this screenshot is from some years ago, right? So this is like 100K in the US, like looking at their standard, and this is, I think, an average level. It's not a senior level whatsoever. Um, this is like a, I would say, a mid-level DevOps engineer's pay, right? Which is really nice. When you look at other jobs, you'd find out that, and people say there's money in tech, but I think there's even more money in DevOps, right? Because you're the one holding the company down most times. If you come one day and decide to just delete everything they have on their deployment environment because you're not happy, that takes the whole company down. So they have to compensate you really well. And that's something you should have in mind. A lot of things are on your neck as a DevOps engineer. You are in charge of making the users happy by ensuring that all this process is adopted properly and things are working smoothly, right? To go to the next slide, I'll talk about some of the practices you need to learn, right? So, I guess that there's the money part, but you also have to have some bit of culture that you adopt, or else you won't get that money, right? So, some of the practices you need to have, apart from your regular work ethics, like you need to properly communicate, you need to make sure that you take ownership of stuff. You don't just wait till they tell you that the server is down. You have proper monitoring things in place. You're able to learn these tools to make the whole work easier, right? You also need to ensure that um, practice like continuous integration and continuous deployment are things that you adopt. And these like basically making sure that you're able to build, test, deploy smoothly, right? And there are a lot of tools that help you do this. But then, there are things that you should be quite aware of and make sure that you have implemented. As much as possible, you want to make sure that almost everything you're doing is done by code and is also done via automation, right? So that they don't call you one day and say, how did you do this? And you can't even remember because you're not sure. But then when you have continuous integration and continuous deployments followed to the core, you would see yourself having pipelines for everything and having everything automated, which is really good because anybody that joins the team would understand how these things work, right, easily. Um, and one very nice concept or practice I like is also GitOps. So when we started, we're talking about DevOps, right? The initial slide had development operations, and this is more like Git operations, right? You might have heard about Git. Git is different from GitHub, right? It's like hmm, Git is the underlying infrastructure, right? The underlying technology behind GitHub itself. GitHub is just UI and Flex, right? Basically, them making life easy for you. Git itself is the version control system that you use to manage how you work across different teams. Now, imagine a scenario where you have a Kubernetes cluster as your deployment infrastructure, and then you're working with like multiple developers. You want to make sure that developers themselves are able to get deployments done smoothly. Um, I'm not saying this is what it looks like in summary, because there are a lot of things that are missing here. Things like your build, things like your testing. But now this is mostly focusing on deploying to Kubernetes, right? Those pipelines are things you'd figure out also. But now GitOps is mostly an approach whereby developers can push to a Git repository. It can be on GitHub, it can be on Bitbucket or GitLab. And then you have tools that constantly listening to changes on that repository. And then once they detect there's a change on that repository, they automatically apply those changes to your cluster, right? And this is something I think you'd probably find us doing a lot as DevOps engineers, where we have a repository that is the single source of truth for um, everything we want to deploy on the server, right? Because we don't want to find that there are things on this server that we don't know of, right? We don't want to be shocked by sudden changes. So we want to make sure that the single source of truth is coming from a Git repository. So yeah, okay, my FAQ slide is empty. I'm going to take questions now, and I think I'm just going to also answer a few questions I have in my head. But yeah, let me check the chat first and see if there are any questions. Or are we? I mean, do we allow people on mute and ask questions?
No, preferably they can just drop their questions in the chat box.
Okay, cool. While they do that, I'll talk about a very common question I know of, which is mostly where people compare some of these career paths together, right? People compare things like cloud engineer, developer with DevOps, right? Um, for developers, right, for basically things like front-end development engineer or back-end developer, right, all those roles are code specific. They are mostly focusing on building features. So if you look at the diagram here, your whole developer roles and developer titles, this is where they start and this is where they end, right? They don't go beyond coding, planning, testing, and building, right? But for operations, for a DevOps engineer, you're mostly doing everything else also. Um, for a cloud engineer, I wouldn't say so. I mean, DevOps, trust me, sometimes these names just make us confused. I think it also depends on the company you're working. I know a lot of Nigerian companies that hire you as a developer, and trust me, you're doing the job of a secretary. But just try to understand the requirements for the company itself, what you'll be doing specifically. If I was to tell you what a cloud engineer would be doing, I would most likely say, just focus on ensuring that the cloud is well configured and things like Google Cloud, Amazon Web Services, and AWS, right, or Azure are configured properly for your deployments. And they don't really have to do with developers, right? But then you find companies where a cloud engineer would most likely be doing much more. So things like cloud engineering, DevOps, site reliability engineering, they are very similar. And it's good to not isolate yourself into a title and say you're just this person, you're not going to do any other thing else. It's bad because you wouldn't learn too much and you're restricting yourself from opportunities. So if you want to, for a start, while you are starting, it's best to just assume that you're going to do everything: cloud engineering, DevOps, site reliability engineering, and whatever name they decide to come up with in future, right? Just know that you are well versed within that space of being able to get applications deployed and also make sure that users are happy. It is different from development. I would not say you should invest time in learning the latest JavaScript framework because it doesn't end. They have new frameworks every day. So that's not your business per se, but then it's also good to um, understand how code, right? So from a high level, you should understand what backend does, what front end does. You might be able to dive into their code once or two times, but don't invest too. If you're focusing on being a DevOps engineer, I wouldn't say you should invest too much time into learning the latest new framework, right? Um, because it never ends, and that's a different part completely. Yeah, I can't see any questions on the chat, so it looks like I've confused everybody. Um, does anyone have? Please don't feel shy. You can just drop your questions on the chats.
Also, it's woman. Probably you got confused along the way or something, but as Tim just said, don't be shy. You can just shoot any question. Nobody here will judge you for anything, please. So let's get your questions, guys. Okay, so I think we have a question in the chat box.
Hmm. Is DevOps engineering a subset of cloud engineering? Uh, I would say it's a superset because I might be wrong, but then I feel as a DevOps engineer, you're not just restricting yourself to just um, you know, cloud. I have had companies where they don't even want to deploy on any of these cloud you see here, like Google Cloud, AWS, Azure. They want to deploy on their own personal servers, right? And that was still within the whole DevOps job description. So that way, I'm not just limited to cloud, but I was also deploying on premise, right, to physical servers. And you have companies that have that policy. I think banks in Nigeria, a lot of them have physical servers, or let's say the financial sector, right? Um, so you'd find yourself deploying applications within a particular environment and not even on the cloud. And that was the DevOps role, like I said. So I feel it's a superset. I feel as a cloud engineer, you're mostly focusing on these cloud platforms, right? And you're focusing on being able to deploy them and manage them properly. As a DevOps engineer, you find yourself switching between AWS and Azure and Google Cloud, the same way you switch between, your mobile applications, right? You're opening this and that because it's your company might decide to use multi-cloud. Sometimes they call it hybrid cloud, where you have deployments in different places for different reasons, and you have to understand like the basics of these platforms to be able to maintain them. So it's not just about cloud, it's a lot about being able to make sure that the applications themselves can be deployed anywhere and they can run smoothly. Okay, Ablai, I think I've answered that. Do we have any other question?
Has been done.
Yes, I didn't get that. So just to round up, I always like opening this guy. Um, Okay, there are two questions. I'll get back to them just once I'm done with this talk. I always like opening this guy because it is very confusing, and most times you brace up yourself when you know that there is a long path for you to go, right? So I'm going to open it up because this is the first talk, and it's good for you to know what we're doing for the next few weeks. Um, Trust me, we're not going to cover everything here, but then we're going to cover the key parts, right? And I'll just talk through what this looks like. I've dropped the link to this on the chat, by the way. So basically, this is a step-by-step guide for DevOps, SRE, or other cloud operations related roles. And first off, they'll tell you to learn a programming language, right? Which is good, right? But then you don't need to invest too much time into this. I would say you learn more of a scripting language, things like Bash or even Python, for example, because Python can be used to do a lot of automation because you'll be you'll be making your job easy when you know how to automate. Um, so that's something that is good for you to know. You would learn a bit of networking. I don't think we'll dig this. Networking is a very different world on its own. But it's also good for you to learn things like DNS, how to connect domain names, how to work with IP addresses and all of that, right, on different clouds. When I do a bit of Linux, definitely a lot of commands we'll be using will be Linux commands. So it's good to familiarize yourself with a bit of Linux commands, right? And this is something you can also kick off on your own and sort of get into it, right? There are general concepts you might have heard in the past: HTTP, HTTPS, FTP, SSL, SSH. Um, it's good for you to know what these things mean, because you find yourself using them one way or the other, right? These are mostly Linux tools, right, that you get to use quite often. Um, for monitoring, you find yourself using tools like this on Linux also. Um, Now to the favorite part, right, which is Docker, Argo CD. You see things like GitOps. Service mesh is a very advanced feature which you might not need for now, but then it's good to also just understand what it does and maybe know that at some point you might need it. A lot of applications run behind web servers, so you need to understand things like Nginx, Tomcat, and all of that. Um, these applications run on servers, which is also known as infrastructure, and you need to know how to provision those infrastructure rights. And that's where things like infrastructure as code comes in. So you have guys like Terraform, Pulumi, CloudFormation, and the rest. When you provision this infrastructure, you need to configure them. So, say for example, I use Terraform to create an Ubuntu 22.04 VM and I want to install Python on it, I can use Ansible for that configuration, right? So IAC is mostly to provision, and these configuration tools can be Ansible, Puppet, and the likes. Um, and it continues like that down to monitoring. We talked about things like Prometheus earlier. Developers would want to see logs, so that's where you have things like Elasticsearch, right? So they have deployed the applications now, but they want to see the logs. So you can use different tools for that. And then cloud providers. Now, a very common question is, should you know all the cloud? The answer is yes and no. It's good to have an idea of how, trust me, a lot of features are quite the same in all these clouds, right? Google Cloud calls their VM, I think, container engine. AWS calls theirs EC2. Google Cloud calls their buckets GCS buckets. AWS calls theirs S3 buckets, right? So you most likely would find every feature you have in one cloud in a different cloud. Yeah, and you can get your hands dirty by practicing most of these things, right? So I'll take the questions on the chat. Monday asked, how do you transition from backend engineer to DevOps? I think looking at this diagram, it's quite easy. As a backend engineer, you would have learned a programming language, definitely, right? You would have most likely been using things like Python or Node.js. Now, that's going to make it easy for you to be able to automate stuff when you need to, but then you still have a long way to go because when you look from down here, you still have like so many things to learn. You might have worked with things like HTTP as a backend engineer because you're building HTTP based applications, but then you would also still have like a lot of learnings to do, but then it makes it easier, right? um how is DevOps helpful to developers? Elizabeth asked, I think it's helpful because if you look back at the diagram, right, the whole developer cycle ends on the left here, right, this part. As DevOps, you understand how to build and deploy, which is mostly what you do on the right. And without this experience, right, you mostly will just have your code in Docker Hub, and nobody's going to be able to use it from there. You need some level of DevOps experience to be able to get things deployed and help it make sure that it's working smoothly, right? So yeah, for a start, most developers just do their own DevOps by themselves on things like Heroku, on things like Netlify. But then when you're working in a company and you have serious customers, you want to ensure you have proper DevOps. Um, okay, yeah, to those that are not backend engineers before, right? Those that don't have any prior knowledge, it's basically even better because you're not going to get yourself confused. Um, maybe not better, but then you are starting on a new slate, and you'll be able to pick up these things one by one and understand them from the DevOps point of view. I'm going to stop here and let Amina take over. Thank you very much, everyone. If you have questions, I think you can just put them on the WhatsApp group, and I'll try to follow up later. Suleiman, pipeline means this thing, right? So a pipeline is mostly just the a combination of instructions that will help you do something, right? So you can have a pipeline that builds and deploy, right? So it's basically a combination of steps that's going to help you build and deploy. So yeah, thank you everyone, and bye. Amina.
Okay. Um, Thank you, Tim, for that wonderful insights and your expertise that you shared with us today. And I hope that the participants of today's class, like you found this very informative and engaging. So before we wrap up, I would like to remind everybody to please stay connected. Always check the WhatsApp group for the next update regarding the next class, which will be next week by God's grace. So just stay up to date on future events and make sure to engage with Gold and team in the group because you'll be opening yourself to like a whole um, wild range of opportunities. So I also like to thank the Google Developer Student Club for making this event possible. I don't think without their support, we wouldn't have been able to bring together such a talented group of speakers. And finally, I want to thank each and every one of you for attending and for your active participation. I mean, though some of us were shy, a few of us asked questions. So thank you for participating in today's discussion. We appreciate your time and energy, and we hope that you've gained a lot that you can apply to your work. And thank you. Next week, we hope to see you. And don't forget to check the roadmap of what you'll be expecting next week. We're going to be talking about cloud platforms, and Gold will be the one hosting us next week. So thank you so much, everyone, for coming. If you have any questions, don't forget to you can drop it in the WhatsApp group. So thank you, everybody. Have a nice day. And that is all.